Every single time you stream a movie or you send an email or ask an AI a question, you're tapping into this massive invisible infrastructure, one that has a pretty big secret. So today on The Explainer, we're going to pull back that curtain on the hidden costs of our digital world.
It seems like a simple question, right? But the answer? It's not some abstract cloud floating up in the sky. Nope. It's a very physical reality, all housed in these enormous buildings that have equally enormous consequences for our planet's resources. Okay, let's get into it.
So here's how we're going to break this all down. First, we'll get clear on what these data centers even are. Then we'll look at their staggering demand for power and what's causing that demand to just explode. After that, we'll uncover a hidden cost, water. And finally, we're going to ask who, if anyone, is actually managing all of this. All right, first things first. Before we can really talk about the impact, we need to be crystal clear on what we're actually dealing with here.
So from now on, whenever you hear someone say the cloud, I want you to picture this instead. A huge, highly specialized, super secure building, just packed from floor to ceiling with computer servers, storage drives, and all the networking gear that makes our internet work. It's literally the engine room of the digital age.
And yeah, they come in all shapes and sizes. But the real story here, the thing that's changing the game, is the trend toward these so-called hyperscale facilities. I mean, some of these things are as big as a small city, covering thousands of square feet and just humming with energy. And this is where the scale just becomes truly mind-boggling, because powering these digital cities, it takes an almost unbelievable amount of electricity. This is where the story gets really, really interesting. Just check out this number. A report from Lawrence Berkeley National Laboratory estimated that in 2023, U.S. data centers chewed through about 176 terawatt hours of electricity. I mean, that's a number so big, it's kind of hard to even wrap your head around. So let's try to put that into perspective. That one single industry, just data centers, used about 4.5% of all the electricity consumed in the entire United States for a whole year. And you know what's crazy? That's before the real boom even started. And you can see where this is headed, right? Some projections show that by 2028, that demand could nearly triple, maybe accounting for up to 12% of all U.S. electricity. That is a massive, massive strain on the power grid, and it's coming at us fast. Think about this for a second. Just one of those big hyperscale data centers can pull 100 megawatts of power, sometimes even more. That's the same amount of power needed for a city of 80,000 homes. And they're building these things at a record pace. So what's throwing fuel on this fire? I mean, what is driving this incredible, almost vertical surge in energy demand? Well, one technology stands head and shoulders above everything else: artificial intelligence. See, training and running the large AI models that power all these new tools, it just requires computational power on a scale we have never seen before. It is a completely different beast than just, storing photos or hosting a website. And here's why. Your standard computing relies on CPUs, central processing units, but AI training needs the immense parallel power of GPUs, graphics processing units. These chips are absolutely incredible at what they do, but they are also incredibly power hungry. They draw way more electricity than a standard CPU. The energy footprint for just one single AI project is just wow. One analysis figured that training just one large AI model took about 50 gigawatt hours of energy. That is enough to power a city like San Francisco for 3 whole days. And remember, companies are training hundreds of these models all the time. Okay, so you've got all of this electricity running through millions of tiny chips. Well, that creates a secondary, but equally massive, problem: an unbelievable amount of heat. And trying to get rid of that heat, that introduces a whole new resource demand. Now, this is what's really wild. It's this huge efficiency challenge. For every dollar you spend on electricity to actually power the servers, you have to spend almost another dollar on electricity just to run the cooling systems to keep those servers from, melting. Almost 40% of a data center's entire power bill can be just for the AC. So this leads to a really critical trade-off. You've got this choice, right? You can use traditional air-cooled systems. Think giant air conditioners that use a ton of electricity. Or you can go with more efficient water-cooled systems. But here's the catch. They consume astronomical amounts of fresh water, which just evaporates away into the air. So, how much water are we talking about here? Well, the International Energy Agency estimates that a single 100 megawatt data center can use as much water for its cooling as 2,600 American households. That's a huge, huge strain on local water supplies, especially in areas that are already dry.
Okay, so with this massive accelerating impact on our energy grid and our water resources, you'd think there's some kind of really robust government oversight, right? Well, the reality is a lot more complicated, and frankly, it's a little bit concerning. So here's the bottom line. For the vast majority of data centers out there in the private sector, there are no legally binding, comprehensive standards for energy or water use. Yeah, there are some voluntary programs and some rules for specific pieces of equipment, but there's no big overarching framework to manage this explosive growth. And here's the kicker. It's pretty hard to manage a problem that you can't even measure. The government has struggled just to collect basic data. Get this, a pilot study back in 2021 tried to survey 50 data centers about their energy use. They only got 9 responses. 9! This lack of mandatory reporting makes it so hard to understand the true scale of what's going on. Now, there are some efforts underway to change this. People are proposing laws like the Clean Cloud Act of 2025. And really, the whole idea is just to give federal agencies the basic authority to collect this vital data on energy and water consumption. But for now, the future of that kind of regulation is pretty uncertain. And that leaves us with this final critical question. Our digital world, powered by an ever-hungrier AI, is demanding more and more of our physical resources. So the question isn't really if we need to manage this demand anymore, it's how. And who is going to be responsible for making sure our digital future is a sustainable one?